Hello, Lacey students. Miss Marsh speaking. Today we're going to look at functions, domain, and range. Oh my! So, what you're going to want to be able to do by the end of this video, you're going to want to be able to figure out what is the domain and range of a relation, and then also, can you determine if a relation is a function or not? So, what we're going to look at is basically like a function machine. You're going to have input values, like 1, 2, 3, and 4. And we're going to put that into what's known as a rule. And a rule is 2x plus 1. It's an equation of some form. Once we plug in our input values, we get output values from our rule. So my particular output values would be 3, 5, 7, and 9. This is what's known as a relation. A relation is a set of ordered pairs with domain x values and range being your y values. So now, there is a more specific form of relation known as a function. A function is a relation where each value in the domain, or each x value, is paired with exactly one range value, or y value. Okay, so each x value is paired with exactly one y value. Now, consider this. I have this pop machine right here. And I know that input values are the buttons that I'm pressing. So if I press a bottle for a bottle of water, the output is going to be the bottle of water that comes out. Now, two buttons can lead to the same output. So notice how I have two bottles of water here. If I push either one of those buttons, I should get a bottle of water, right? It won't get like a green tea or something. I should just get water. Now, but can one button lead to two different outputs? Let's say I push this blue Gatorade button right here, and I get a blue Gatorade. My friend right behind me pushes the same button, and she gets a green tea. That's broken, right? The pop machine would be broken. We'd be angry. I wanted blue Gatorade. So that is the difference between a function and not a function. Not a function would be me pushing blue Gatorade and me getting green tea. I wanted blue Gatorade. So one button can only lead to one kind of output or one kind of beverage coming out. Other real life examples. A function example would be state and capitals. Each state only has one capital. Like North Dakota only has Bismarck. We don't have multiple capitals. But a non-function would be a state to its senators. So our state senators are Hoeven and Heitkamp. So notice how one state has two outputs, aka one button on our pop machine is leading to a pop and a water. That is not a function. I don't know which, if someone says, well, what's your state senator is really rocking out here, I don't know which state senator you're talking about, because there's two of them. So let's look at a few examples. So there's one thing called a table. Now, your table, to find your domain and range, you're going to find your x values. Your x values are your domain values. So my domain values would be 0, 1, 2, and 3. And I'm going to put them in these curly braces. To draw a curly brace, you're going to do an S and then a backwards S. That's going to get you a really nice curly brace. Your range is your y values. So you're going to want to look in your table, and my y values are -7, -4, -1, and 2. You're going to want to put them in numerical order in your domain and range listing. Now, is this a function? What you need to ask yourself, does each x go to only one y? Well, this x just goes to one y. This x just goes to one y. That one does, and that one does as well. Yes, this guy is a function. Each x only has one y attached to it. Let's look at a mapping diagram. Basically, a mapping diagram is the table but put with two circles. So in the first circle, I have my x values, and in the second circle, I have the y values. So my domain would be my x values, which is 1, 2, 3, and 4. My range would be B, C, and D. Put them in alpha numeric order, right? Now, does each x value only go into one y value? Let's see. So 1 just goes to D, 2 just goes to B, 3 just goes to C, and 4 goes to C. But now, is each x value going only to one y value? Yes, this is still a function. Basically, 3 and 4 are our two water buttons on our pop machine. But let's take a look at another example. So notice how my domain would be -8, -5, and 7. And my range is -6, 1, and 2, and 3. Now, notice how -8 has 2 arrows coming off of it. That is me pushing a water button and getting blue power weight and water. That's not going to work. This is not a function because -8 has 2 arrows coming off of it. Okay? That's a good way to look at it. If one of your x values has 2 arrows coming from it in a mapping diagram, you know it's not a function. Let's do this with ordered pairs. Now, I find ordered pairs very hard to be able to find domain and range and identifying a function. So, I'm going to make ourselves some mapping diagrams. So my x values are going to go in the leftmost circle, and my range values, or my y values, are going to go in the right one. Notice how I didn't write 2.5 twice. I only wrote it once. You only need to write each range value only once. -2, I know that goes to 0.5 because those two are in the same ordered pair. 0 goes to 2.5, 4 goes to 6.5, and 5 goes to 2.5. Now, does each x value only go to one y value? AKA, is there only one arrow coming from each x value? Only one there, only one, and only one. So I know my domain is -2, 0, 4, and 5. My range is 0.5, 2.5, and 6.5. And it is indefinitely a function. Because your domain, once you separate it into this mapping diagram, your domain and range comes pretty simple to find. Let's do another mapping diagram. So I got my domain values of 4, 5, and 6. Notice I didn't write the 6 twice because I only needed to write it once, because you could just put multiple arrows. I have my range values of 3, 4, 5, and 8. And then I'm going to do my mapping here quick. Domain 4, 5, 6, range 3, 4, 5, 8, right? Now, notice, it's not a function. Why? These two, 6 has 2 arrows coming off of it, aka 6 is the water button, and I'm getting a green tea or a water when it comes out. That is the good way to notice. Notice, another way to look at it is if I have the same x value but 2 different y values, I don't have a function. Now, this can also go further into graphs. So consider this. I have this gathering information about people and their heights. I want to make 2 graphs from this. So I have the height, or their names on the bottom, their height going up, and I get this wonderful graph here. Notice, though, each x value is only repeated once, right? So that is a function. Each x value only has one y value. Now, if you look here, though, 5 has 2 y values, right? Because one's for Bill and one's for Ryan. That's not a function. Each x value of 5 only has 2 different y values. That can't happen. So there's another way to look at this if you have a graph. That's called the vertical line test. The vertical line test tells us a relation is a function if a vertical line drawn through its graph passes through only one point. AKA, if you take your pencil and move it from left to right across a graph, and it crosses the graph more than once. So basically, if it hits twice on your graph, that is not a function. Let's take a few examples here. So I have this graph here. We looked at this before. It's the height versus name. And I'm going to take my pencil. I'm going to go across. Nothing there, so I don't have to worry there. But it looks like I do hit twice there, don't I? So is this graph a function? No, because I hit twice. Once there and once there. With my pencil, I can only hit one point on my graph. Let's try it again. What about this? Take my pencil. Let's move across. Right there, only hit once, right? Only hit once there. Is this graph going to be a function? Well, yeah, I only hit it more than once, right? So on my graph, as I move my pencil across, I only hit the graph once, not twice. Let's take a look at another one. So I have a circle here, and I'm going to take my pencil. So I only hit once right there. Move across a little bit more. Ooh, I hit twice there. So is this graph going to be a function? It's not, because I hit more than once. Notice how when my pencil went across this point, I hit it twice. Doesn't matter if it only hit once here. It hit twice there. So this is not a function because it fails the vertical line test. And that's the end of this video. See you later, Sabers.